All right, in this video we are going to talk about the graphs of the sine and cosine functions. Okay, so the first thing that we are going to do is to sketch the graph of sine x by plotting some points. And so we're going to get a table of points here, and then just sketch those on the coordinate axes. Okay, so one thing you might notice that's different from what we were doing previously is that now we are using x as the variable in the that we're using to take the sine of the argument of the trigonometric function. We're using x now instead of t like we were using before. Just because generally when we're talking about graphs of functions, we generally use x and then the y value, and so the y value would be sine of x here when we're talking about functions. So it's really not really any different than what we were doing before. It's pretty much the same. We're just using a different variable here because it's more traditional to use it that way. And you'll notice at various points in the course we'll kind of flip back and forth and use different variables. Okay, so you might ask, okay, where are these points that you're getting coming from? First off, right, and they are coming from the unit circle. Remember before we talked about the special angles and how they are marked off on the unit circle. And notice we will be using radians to graph this out, okay, as is standard to do that, okay? So when we're talking about the graphs of these sines and cosine functions, we mean that the angles are measured in radians. Okay, so with sine, right, so first off we're going to start over here with 0 radians, right? And with 0 radians, the sine, remember, is the second coordinate. So 0, 0, that's where this point comes from right here, 0, 0. And then next up on the unit circle is pi over 6, right? We know that the sine of pi over 6 is equal to 1/2. So that's where this next point comes from. All right, and then for pi over 4, we get square root 2 over 2. So that's where this third point comes from. And then we just kind of continue that process, working our way around the entire unit circle, okay? All right. So let's take a look at that process. I'm just going to use Desmos to plot those points. All right, and on Desmos you would just use a little table right here and then start typing in the points. The first point was 0, 0, and you can see that that shows up right here at the origin. All right. The next point was pi over 6, and for sine it was 1/2. The next angle, or next point that we had, was pi over 4 and square root 2 over 2. So you can see here. So I'm just basically following along the unit circle here, but I'm graphing it as if they were ordered pairs. Okay, so the next one would be pi over 3, square root 3 over 2. The next one would be pi over 2, 1. And so notice that's kind of at the top of the unit circle, pi over 2, 1. The next value would be 2 pi over 3. The next one would be 3 pi over 4. The next one would be 5 pi over 6. The next one would be pi and 0, back like this. So you can start to see this is kind of what the graph would look like here. And you can see we are using these points, right? The radian measure of the angle would become the x coordinate on the graph, right? And then the second coordinate of these points would be the y coordinate, right, of the graph over here. And we can basically do that, and you can see we're going to get this pattern right here, these points. All right, so I'm going to go ahead, and I've already done this out because just to save a little time, right? And so when I do all of the values, all those points that we got from these points on the unit circle, this is what it would look like, okay? All the way from 0 to 2 pi. All right, we can keep going, right, on that. If we kept going, right, the next point would be looking at the unit circle, right? If we went all the way around, one time around the unit circle, 2 pi would be here. I don't like that they probably should mark this as 2 pi as well. And then the next one would be 2 pi plus pi over 6, right? That would be 2 pi is plus pi over 6. Getting a common denominator, that would be 12 pi over 6 plus 1 pi over 6, which would be 13 pi over 6, and it would be at 1/2 again. So this would continue to go 13 pi over 6, and then 1/2. Oops, this is the wrong one. Pi over 6, 1/2. All right, and so what's going to happen, the more points I put on here, it's going to keep following the same pattern over and over again. The pattern that we saw from 0 to 2 pi, where sine started at 0, 0, and then it went up to this highest point at pi over 2, 1. Right, and it's no coincidence that that's also the highest point on the unit circle. And then it started going down. It crossed the x-axis here, right, at pi 0. And then it went down to the lowest, our minimum point down here, 3 pi over 2 minus 1. Again, it's no coincidence that that is the lowest point on the unit circle as well. And then it kind of went back up. And again, we can keep following the same pattern, but if you'll notice, the x values, right, which will be the radians, will be bigger. So they'll be farther to the right or farther to the left if you're going backwards. But one thing to notice is that the y values are going to be exactly the same because we just keep looking, we're looking at the sine, so we would just keep looking at those second values. So they're going to repeat over and over again. All right, so if you graphed a lot of these points out and then kind of connected the dots, the more points you graph, the better view or better view that you will look. It will look like this graph right here. All right, and so this is the graph of the standard sine function, right? It passes through the origin right here, okay, and it goes up and then crosses back over the x-axis, goes down to this minimum point, and then comes up back again, back up to the x-axis there. And then you can see it just kind of repeats that pattern over and over again, right? It goes up, right, comes back down, goes down to this minimum point, comes back up to the x-axis, and it repeats over and over again like so. One good thing you can do on Desmos is to, if you adjust the step over here on the x-axis, you can put in a pi in there, and it will change it so that the x-axis, right, is multiples of pi, and then you can zoom out and it can show you exactly where those points of interest are, where it crosses the x-axis right here at 0 and pi and 2 pi, and then also where the highest points are. You can see that that the maximum point for the sine function, the first one to the right of the y-axis, is up here at pi over 2, and then 3 pi over 2 right down here at the bottom is where the first minimum value to the right is. Okay, so that's what the basic sine function looks like. So you see how the sine function repeats over and over again. that same pattern. So a function that does that is called a periodic function. And all of the 6 trigonometric functions that we are going to talk about, they are periodic functions. So here's the technical definition of the periodic function. A function is called periodic if there's a positive number p, such that f of x plus p is the same as f of x. Okay, and so that smallest value for which that's true is called the period of the function. All right, so the period of the sine function, right? Basically, what the period is, it's the smallest positive value over which it repeats. And so you can see that for the sine function, the period is 2 pi, right? Because the sine function, if you start at 0 here, it's going up to a maximum point, right? And then it's going down, crosses the x-axis, it's going down, hits this minimum point right here, and then it's going back up, and here it's crossing the x-axis, headed back up, just like it was at 0. Right, at 0, the graph was crossing the x-axis, going up, and now it's starting to do the same thing. So the cycle is starting to repeat. So 0, right, the distance from 0 to 2 pi is 2 pi, right, on the number line. So that is the period of the sine function. All right, so the sine function is periodic with period 2 pi. And then if you look at this definition of periodic and applying it to the sine function, it says that the sine of x plus the period, which is 2 pi, so in this case sine of x plus 2 pi would just be equal to x for all values of x. And you can just see that if you take a look on Desmos, if I did something like sine of 9, let's say, it comes out to be that value right there. If I do sine of 9 plus 2 pi, right, you can see I get exactly the same value there. And it's nothing magical about 9 if I change that to anything like pi over 12, right? That's always going to be true, that these numbers come out to be exactly the same. Okay? All right. So now that we know what the graph of the standard sine function looks like, there's a couple of things that we want to take a look at, and that is the domain and range, right? So remember back from college algebra, the domain of a function is the set of all real numbers, right, that you can plug into the function so that you get a legitimate real number output for the function. So basically, it's the set of all numbers, real numbers, that you're allowed to plug in. All right, and the domain of sine x is negative infinity to positive infinity. That means it's defined in all real numbers. You can plug in any number you like into the sine function, and you will get a legitimate value out. So you could plug in whatever number you like in here. It doesn't matter, and you won't ever have any problems getting a value out like this. Okay, so its domain is all real numbers. Plug in any number you like. Everything's going to be fine on that one. All right, and then the range of sine of x is -1 to 1. So remember what the range of a function is. It's the set of all outputs, right, for numbers in the domain. So these are the numbers that you're getting out, right? So if you notice, right, the biggest number that you can get out of the sine function is a +1, and the smallest number that you can get is a -1. And that makes a lot of sense when you think about, hey, the sine function, it comes from the second coordinate of these points on the unit circle. So what's the biggest possible one? And the biggest possible y value of any point on the unit circle is 1 up here, okay? So 1 is the top point on the unit circle. And likewise, the smallest point on the unit circle, the one with the lowest point, I should say, the one with the smallest y value, is down here at the bottom of the unit circle, right? So -1. So it's impossible to get like a number of 15 for the sine, because, well, that's not the second coordinate of any point on the unit circle, okay? So the numbers that you get out for the sine function are always going to be greater than or equal to -1 and less than or equal to +1. All right, so whatever you put in there, you can see these numbers, right, are always going to be in that range, okay, between -1 to 1. Another way to look at it is if you look at the graph, then all of the points on the graph are trapped in between these horizontal lines at -1 and 1. The graph never goes above this green line. It never goes below, right, this purple line here. It's trapped in between everywhere, no matter how far you look to the right or how far you look to the left, right? The graph is always trapped in between those two lines. All right, next up we want to do the same thing with cosine. So it's pretty much the same thing. I have these points and I want to plot them out. And the main difference is that, I'm going to look at the first number, right? The x-coordinate are going to be the measures of these angles. This is where I got those points from, just like I did for cosine. So, and the difference, right, is that for the cosine, it's the first coordinate, right? So going by these special angles on the unit circle, right, the first point would be 0 and then 1, right? And so you can see that's where I got this. And then the next point would be pi over 6 square root 3 over 2, right? The next point would be pi over 4 square root 2 over 2. So you can see that's this point right here, okay? And so that's how I generated these points, by just going around the unit circle one time like that and looking at the first coordinates. All right, and again, just to speed things up, I went ahead and plotted all of these things out. And that's what the picture you would get looks like, okay? And then if you kept going around the unit circle, you would see you would get a bunch more points over here that follow the same pattern, and a bunch more points over here that follow that same wavy pattern. Okay, and then if you connected those up, right, and plotted a lot of those and connected them up with a line, that's what the graph would look like. Okay. And so you can see it looks a lot like the sine function, right? The main difference is that at 0, the cosine starts up here at 1, right? So if you look at sine, let me turn all of these other things off. If you look at sine, it starts at 0 and goes up, right? The basic sine function. And then if you look at cosine, it starts up at 1 and goes down, like so. Let me turn this. Put pi for the step. All right, and so you can see it starts up here at 1, right, and then it goes down, crosses the x-axis at pi over 2, right, goes down to this minimum value here at pi, right, at pi the minimum value is -1, then it goes up to 3 over 2 and crosses the x-axis again. It goes up to 2 pi, and then it's starting to go down again, right? Just like it did here. So again, the cosine function has a period of 2 pi. It repeats, right? It looks the same every 2 pi units. So it's periodic with period 2 pi. The domain of the cosine function is the same as for the sine. It's exactly the same. You can plug in any number you like into cosine and get a legitimate output from that function. Okay, and those outputs, the range, right, is going to be from -1 to 1. So those outputs have to be greater than or equal to -1 and less than or equal to 1. All right. And so they're very similar to each other, the sine and cosine functions. Here they have a lot of the same properties. They're different, obviously, right? But a lot of the things are the same. They have the same period, they have the same domain, they have the same range. All right. So that's an intro to the basic functions, sine and cosine. And then in the next video, what we are going to do is to start looking at transformations of those. So we're going to look at these two functions and see how they relate to the basic sine and cosine functions that we just talked about.